Okay, so 295, let's just get some answers from some of our friends here. What'd you think for 1? 4 and... That's true. 2?
I don't have it.
Okay. Why don't you just join us on that page, see if you can figure out 2. How about 3? Or we skip 3. How about 4?
4, 3.
And
Negative
3.
3.
5?
20 and negative 20.
20 and negative 20, all true. When they use the words, you have to have 2 answers, a positive and negative version of the thing that we had. 7.
So, is it -7/6?
It is -7/6. 8.
-19/3.
-19/3. 9. 10.
Extra 1, -21.
Just one of those. Which one do you think? Good peek at the book at 10. I'll come back to you. 11. Ready?
11. -0.
It is. 13. 0.3. 14.
0.06.
Not quite. Let me come back. 14. 16. Okay, let me come back. 16. And then the game's going to change on 17 a little bit, so we'll pause there. On 7, when they use that radical sign, that's a way they're communicating to you that they only want
Positive numbers?
positive numbers. One answer I would have taken also as a good idea. So they just want one answer for those 7 to 16. When they were using the words on 1 to 6, they wanted 2 answers, both the positive and negative version of things. What was the positive version of the answer called when there were 2 of them? P-word. It's also the name of a job that people do, including me.
Joe.
A job that starts with P.
P job. Principal?
Principal. It's called the principal value.
Way to go.
Let's see. 2. You have a shot at that one?
I don't think I even know how to do it. I didn't watch the video.
Okay, we're just doing the square root of 225. You should have a button for that. Okay. You ready, Fritz?
21.
21. Yeah, 10 is positive 21. I agree. 14
0.6.
is 0.6. 15, we skipped 15. We were doing 16. It is 0.12. Is there anybody else fixing other than we're about to get to, I think? Yeah, it's a button issues.
Button issues.
Maybe use that little pink calculator. Might be your
Okay,
friend.
figure it out.
I found 15.
Yeah. There's going to be 2 answers though. It's 15 and it's
Negative 15.
negative 15.
Okay.
That was a part.
Anybody need help up to 16?
You want me to show you what I did?
Yes.
Okay, starting on 17, they want us to start to add on something to about half of our answers. What is getting added on to about half of our answers starting on 17? Bars. When do we do the bars?
If it's adding, you do it over the whole thing. If it's
That's true. But what about the problem lets us know bars are in play, bars are out of play?
Whenever it's positive.
Odds
Whenever it's
and
even.
evens. Which one is yes bars?
Even.
Even. Even what? What's that little number in front called?
Index.
An index. What if you don't see an index?
Then
Then it's a 2. So on the 17 to 25 group, are the bars turned on or are the bars turned off? On. Because all the indexes are 2s. They all need some sort of bar consideration there to make sure things are positive. So 17, do you have an answer with bar? 17?
4 and then X in the bar.
Yes, 4x, only the x is in bars. What's the first one where you wrap the entire answer up in bars? Anybody who...
adding.
Where though? Which problem number has something wrapped up in bars? Like the whole answer.
21.
21 would, we skipped 21 then.
Oh, well, 22.
22. 22 would go 5 minus b, the whole thing in bars. If you wanted to do 23 and 25 successfully, what would you have to do first?
Factor.
Factor. And I'm going to stop the come around because we seem like we're a little hit and miss on whether people did this or whether they got that far. Did anybody run into any issues on how to do anything on the remainder of the ones we didn't talk about? From 20, we got about halfway to 21. We worked to 52. Anybody have anything that you're like, hey, wait a minute, what does this do? Let's do a couple answers here and there. Let's look maybe like one from each group just to make sure we know what we're doing. So 26 did a cube root. Anybody yell an answer to 26?
3.
It is 3. If you go to do 34, it's going to have a decimal number and then parentheses. Anybody 30? Y minus 2 is in parentheses. What did you say for the decimal? It's close to 0.2. It'll be a 0.02. 35, a thought,
I think I got a 5.
is a 5. 46, is it 10 or negative 10?
10.
It is 10. Anytime you have an even index, you want to go positive numbers only. How about the final one? 52?
21. That's why in parentheses.
I don't know where the 21 came from.
Oh, it's just a 2.
Maybe, yeah, just a 2xy. Bars, no bars.
Bars.
I hear two different ideas.
You know, with no bars.
Why do you say no bars?
Because I just got a feeling.
Got a
Joey said it
feeling.
with confidence, you know?
He did? He convinced you?
Yeah.
Because it's an odd index on 52 means no bars. So 2xy. You could do parentheses, but you don't need them. The parentheses, they're like there whether you write them or not. We sort of skipped around a little bit there. Anybody, did I skip anything that you had, something you wanted to know about it? Anybody puzzled by 295?
19, you needed around the C.
19, we need bars around the C. And then the 7 would turn positive. 19 would have a positive 7. And then a bar around the C. Is that okay? Anybody else, anything? 295, question? Okay, so if those are done well, send them down. If they're in process, get them soon. We're up to 7-2. So 7-2, we're going to multiply first, and then we're going to simplify second. And if you look around the board, there is a ton of problems on the board, which is probably good news generally to your life. What does it generally mean when there's like a million zillion problems?
All pretty easy.
They're all pretty easy to do. So there's nothing really like super hard here. If you come in and I have like 2 problems on the board, that's usually bad news. There's like a million zillion problems. So a bunch of variety, just making sure I cover anything that they could possibly do to you. But we'll come in with this. If I go to multiply with an index of k, and I multiply another root that has an index of k, does anybody have a memory or willing to make a guess of how this turns out?
Is it case root?
Okay, so we have 2 different opinions expressed. Somebody said maybe this is a k, somebody said maybe that's a k squared. Anybody else willing to weigh in? It is a k, so we broke the tie correctly. If you have a certain index and it multiplies a root that has the same index, we're going to get an answer that has the same index. To multiply these, they have to have the same index. If they don't have the same index, you have to wait until like 7 or something, like later in the chapter. Some other day we'll worry about that. But for now, indexes have to match. Keep the index the same. Anybody have a thought on what would go under there? It would just be 80. What is that called, the number under there? Radicand is correct. What was this little number called?
Index.
Index. So indexes have to all match consistently the whole way through the problem, and you're just going to multiply the radicands. So we're going to be in good shape with that for a while. We should be able to punch this out pretty quickly then. Cube root of 1.
7. No.
Square root
21.
21.
I didn't see that.
Seventh root,
33xy.
33xy.
5
Fifth root,
6 XY.
6 over xy.
Root
Square root,
X plus Y, X minus Y.
yeah, we're gonna have to like, those invisibly have parentheses. What are we gonna have to do to multiply them? Foil it out.
X squared.
X squared minus 4 would be true.
6 square root.
Sixth root,
X plus 2 to the fifth.
is 2 to the 5th. Because when we multiply, the powers have to
And
add.
8
Eighth root,
6x6.
true.
Square root.
Square root,
X squared plus 7x.
agreed. Because these are like they're in parentheses, whether we see them or not, FOIL it out. And that's the world of multiplying. Again, to summarize, index just stays the same, and the radicands multiply each other. Maybe you have to FOIL once in a while. Anybody a question about the multiply variety of world? Simplify that. If you've been through geometry last year, you have a small advantage because we did this sometimes to our roots. So maybe this is in the memory banks a little better for the people that did that last year. But everybody, I think, saw this in Algebra 1. But like I said, the root chapter is the last chapter of the Algebra 1 year here. So things don't always sink in and pay due the way they do in other parts of the year. So I'll refer you to this little chart that I believe we've made before when we were factoring. I think you've seen this. So it's just a list of squares. So 2 squared is 4, 3 squared is 9, etc., so forth. What we're going to look for, if we're doing square roots, we're going to look for a perfect square, which is the column I put a star on, that goes into the number. That's the radicand.
Oh,
So for 20,
4.
4 goes in.
Got that.
4 goes into that 5 times. We chose 4 because it's a perfect square. It's a number we can do the root of. What is the root of 4? Regular old 2. And the square root of 5, we're just stuck with it. Okay, so
Good job.
you may or may not need to write that in between step. If you like that step, write it. If you don't need it, start skipping it eventually. But for 20, don't do like 2 and 10. Why would 2 and 10 be stupid? They're not on this list. We need a number on this list and a number off this list. So the number that's on the list, you're going to root it, and the other number, you're just stuck with it. So 50. There's only one number on that list that goes into 50. 25. So you could either write down 25 or just think about 25. Who's 25's buddy? 2. 25 times 2 is 50. So our best answer out of this is 5 root 2. Don't get these kind of numbers confused with the indexes, and just be careful you're not a mess. The indexes are like these little tiny numbers that kind of sneak in like in an exponent-y kind of position, but outside the root. These are big old whole numbers that are doing what? They're multiplying. So this is a full-size number, that's a full-size number. The 2 is multiplying the square root of 5. That's a multiplication. So don't get these numbers, those are still called coefficients. Don't get your coefficients confused with your index. 300. There's a bunch of numbers on that list that go into 300. When you have a bunch to choose from, bigger is better. Bigger is always better. It's kind of like if you reduced fractions. Like if I gave you this to reduce, you could start yelling stuff like 2 goes in, 3 goes in, 6 goes in, but you'd have to reduce it like a zillion times. If you kept reducing by 2 and by 2 and by 2 and by 2 and by 2, your best bet is actually 144 goes into both, and instantly you'd get a half. Instead of having to go 72 over 144, 36 over 72, 18 over 36, 9 over 18, 3 over 6, eventually you get there, but it's a drag. Okay, so 300, if you're like, hey, 4 goes in, well that's true, but 4's partner is 75. And who goes into 75? that's on this list?
25.
25. So you'd have to like go and go and go, and it's gonna be a pain. Who's the biggest thing on that list that goes into 300? 100. So if you need to write the 100, do it. If you need to write the 3, do it. If you're comfortable skipping straight to the answer,
10 root 3.
10 root 3. So who can help us with 4? Or half?
4.
Who can help us with 12?
4.
4 goes in 3 times, so answer
2 root 3.
2 root 3. Make sure you root the one number and leave the other on. Question about that for square roots? If I do cube roots, you're not going to look for a perfect square, you're going to look for a perfect cube. And I need to build on another column, that's why I left myself some width. Cubes would be like 8, 27, 64, 125, etc. and so forth. We've seen this list before back when we factored cubes. I think I made you that whole list. So which of those cubes helps you with 24? 8. Age partner, 3. Under the root, we're stuck with 3. And for the cube root of 8, just follow the cube column of 8 back to its origins. That's a 2. So big old 2, big old 3. This is a little 3 index because that had a little 3 index. Question there? So cubes, we're going to look in this list now. The only number on this list that goes into 24 is 8. So 8 goes into 24 3 times. With that. So I'm going to leave the 3 alone. 3 is not my friend. 8 was my friend. 8 was on the list. 8 cube rooted translates back to 2. So that the 2 came from cube rooting 8. The 3 is just what we're stuck with. Okay? So 250. Who on the cube list helps us with 250?
125.
125. 125 goes into that
Twice.
twice. So under the cube root, I'm stuck
2.
with 2. I'm not stuck with 125. 125 was a special one. 125 turns into 5. Question about that. If I go to do fourth roots, make a column of fourths. This would be 16, this would be 81. That gets pretty big pretty fast. We need a number that can help us with 32. 16 helps us with 32. It goes in 2 times. So stuck underneath is the 2. Out front is another 2. Because the fourth root of 16, I just need to trace that back to its beginning. And then I made a mistake on purpose that you will commonly do because you get too excited and move on too fast. The index has to stay alive. If you start with 4 index, we end with 4 index. You start with 3s, you end with 3s. You start with invisible 2s, you end with invisible 2s. Question about that? Over here, let's take on the numbers first. So square root of 16, square root of 40. Are these more like yesterday? Are they more like today? Or is it one of each? What's gonna happen when you try to do the root of 16 or the root of 40?
16 will be fine with 40. They're both fine. The same as today.
Today or yesterday, both? Or what, or split?
16's like yesterday.
16's like
40's
yesterday. The
today.
root of 16 yesterday was
4.
plain old, straight out 4 with nothing left. Square root of 16, 4. Square root of 40,
It's like today.
that's more like today. So who helps us with squares and 40? 4 goes in 10 times. So out comes the 2, in stays the 10. Question about dealing with the numbers. Sometimes they're perfect squares and it's like yesterday, you just do it. Sometimes it's not a perfect square, so you try to break it down. Question about either of them? Okay, how did we do the exponents yesterday? Any memories of doing the roots when I mixed in some exponents?
By the,
What'd you say?
I don't have.
It's not, sometimes yes.
divide them by the
Divide the
index
index into the
number, the
exponent. What's the index when I don't write it?
two.
2. So this we could have done yesterday. 2 goes into 2 once, so you bring an x out. Let me go down and pop this one. Again, index is 2. 2 goes into 6,
Three.
is a 3, so y cubed comes out. Index again a 2, 2 into 8, 4, y to the 4th pops out. 3 into 9,
3. Y and 3.
y to the 3rd pops out. If the index divides into the exponent, did that yesterday, just pop that stuff out. Question about that? Why'd I leave the other half? It
Here's divided to it.
doesn't divide evenly, but it does divide. Okay, 2 goes into 5 two times, so y squared can come out. However, there's some leftovers, the remainders will stay under. When 2 goes into 5 twice and 2 of them come out, 1 of them stays in. So the quotient comes out, the remainder stays in. So if 2 goes into 3,
Once,
1 comes out, and remainder,
one,
1 stays in. So 1 out, 1 in. 2 into 7,
three,
3 out,
one in,
1 in. 3 into 8,
twice,
2 out,
two in.
2 in. Where's a mistake on purpose?
You forgot the index.
Index on who?
The X one right there.
Final one, yeah, we need a 3 there. If this has a 3, keep our 3 alive. Question about this? And we'll take a stroll that away. Okay, so let's do the numbers first. 6th root of 64.
Let's go with two.
It is 2. So we don't have to follow me with the camera, but if you could, if you want to. We could go back over here, and you could add on a 5th column. You could add on a 6th column. 16 would turn into 32, which becomes 64. So 64, 6th rooted, does flash back to 2. How about 4th root of 80? We did start to build a 4th root column over there. Is this gonna work perfect like yesterday?
I don't think so.
No. Does it have a friend like today?
16.
16. 16 is in the 4th root column. 16 into 80
5.
is 5. So stuck underneath
Five,
5. Who's coming out?
4, 2.
2. 4th root of 16 would be a 2. Question about numbers? Then let's take on all this variable stuff. So x to the 11.
Two comes out.
2 comes out. How about stuck in?
1,
1. Because 5 into 11 is twice. 1 left over. How about 5 into 12?
2,
2 out,
2 in.
2 in. Something about that?
At the index.
5.
Index of 5 needs to be cut to 11. I keep doing that on purpose because you're going to end up doing that by accident. I've graded enough papers over my years to know. Stress that to you. Index gets caught. 6 into 15,
Twice,
2 out,
3 in.
3 in. 6 into 16,
Twice,
2 out,
4,
4 in.
6,
6. Something there. 4 into 10,
2,
2 out,
2,
2 in. 4 with 12,
3,
3 out, and
none.
nothing in. How about this one?
Mm,
Y, I need x plus y equals 7 squared.
I'll see what you see it. Yep.
x plus y to the second, and
Out or in?
and
In, say.
You have to have parentheses.
To which one?
In one inside.
Inside
And outside.
and outside. Otherwise, this would only go with the root, not both. You want both of them there. So if this has parentheses, those go everywhere. And then what are we short? Index of pi.
Did you forget the index on the one above that one too? or-
I did. Good catch, thank you. The final one, what are we gonna have to do?
Per our conversation.
Yes. For me to send that message ahead.
Factor.
Thank you.
That's hard.
Factor. How are we gonna factor that?
First, take 2 out.
Take a 2 out.
X plus 1, X plus 1.
X plus 1, X plus 1. In other words, X plus 1 squared. So that none of that really matters. Square rooting 2? You can't do it, so
Stays in.
just stay there. The 2's just gonna sit where it was. How about this?
Outside of it.
Outside. Parentheses. Anytime there's parentheses, leave them on. That's the whole world of simplify. Question about the whole world of anything simplified. Then what's gonna happen in this group? Multiply and simplify. Okay, and that's the way the homework will go. The first bunch of homework will give you a bunch of multiplies that will not simplify. There are some over there with exponents. Why did none of the exponents on this first set matter?
What's good? They're all like 1.
They were, even when they got to be 5s and 6s though. Why did the 5s and 6s over there for the exponents not really affect us?
Because there's only 1. That's what I said. Oh,
It's about their relative size.
Is it they're all like single digit numbers, or is that just the third time something's like that?
Yeah, I mean, that's true, but not quite.
Basically,
What?
They're smaller than
Yeah, what's that outer one called?
index.
Index. If the index is bigger than the power, just let it go. If the index is smaller than the power, that's where we're gonna have to divide it. So, like over there, if you try to divide 8 into 6, you can't do it anyway, so no harm there. So this, at first, I would suggest write down a Rudy answer.
Nice.
90, and then look to that table for help. Sometimes you might get something you can straight out do, like yesterday. Can you do the root of 90 like yesterday? Boom? No. So we look for help. It's a square root, so we look at the squares column. 9 can help us, because 9 goes into that 10 times. So 3 root 10 is our best answer. On a test, I'd probably give you half for this, and then I'd give you a full point for that. If we can't simplify, we want to. Kind of like if you gave me on a test 10 over 20. You get half a point for that. That's not your best answer. This one, temporary,
18.
root 18. Root 18, is that like yesterday, just do it?
No.
No, we gotta look for a friend. Friend is 9, 2 times
3 root 2.
3 root 2. What do you think about this one, temporary?
6 root 48.
Agreed. The coefficient multiplies the other coefficient, make a new coefficient. And then 6 times 8, the radicands multiply to make 48. It's 48 like yesterday. No, most of them aren't like yesterday. 48 has multiple friends. So if we look through the squares list, there's a couple that go into 48. Bigger is better.
16.
16. So 16
4 times?
times. So stuck underneath
3.
3. If this weren't here, what would 16 bring out?
4.
4. But that is there.
24.
24. Because what's this doing?
Multiply.
Multiplying. So the 4 multiplies the 6. 24 grand total. Something there before variables mix in? So temporary,
18.
18,
X and 6.
x 6. 18, it's like today, friend, 9, 2, so out,
3.
3, in,
2.
2. How about x to the 6th? Outs, ins, boths?
Out.
Out. Out how much?
3.
3. Because 2 is the index. 2 into 6 is 3. Something there. Nearing the finish line. Temporary,
16.
16.
Is that a 5?
That is a 5.
So,
8.
We're up to 8.
Y 11.
Y up to 11. Is 16 like yesterday?
No. Yes.
Yes, every once in a while you hit it. So 16 comes out
4.
4 with inside,
Nothing.
nothing. Just root of 16 is 4. X8,
X4.
X4, inside,
Y. Or nothing.
anything, nothing for the X's. Y,
Y.
5 out, 1 left in. Something there. Is it possible you'd get nothing left in?
Probably.
Yeah, it can happen. It's rare, but it happens. This one would be a cube root, x plus y,
To the 8.
the 8th. And then we encountered one like that a couple minutes ago. This is the second occurrence of this.
X plus Y squared.
X plus y squared is out,
In parentheses.
and in parentheses,
X plus Y parentheses 2.
squared is in,
Put the 3 up.
little 3. Something there. Last go round, temporary, 4th root,
X plus Y.
Y.
Is 12.
12,
X plus Y to the 3rd.
x plus y, parentheses, 3rd, anything in?
No, no.
No, we're done. We just referenced that a second ago. Could we have any with nothing in? The answer is yes, once in a while. That's a ton of problems we did on the board. The homework probably has fewer than what we just did, I'm guessing. We're skipping 3s again. We're going 1 to 47, so that's about 32-ish problems. I bet we did more than 32 problems on the board in the last few minutes. So
Can I take a picture of that?
yeah, go for it. You might need to take 2 pictures of that.
Probably.
That's a pretty wide filled up board.
Well, I wrote out most of this somewhere I quit.
297, we're 1 to 47, skipping 3s. You could probably guess what we'll do in 7-3. Dividing is correct. So dividing will be the Monday thing. It's a much smaller board full of stuff on Monday, not because it's harder, but just because there's less variety and you'd have a feel for some of this by then. But dividing Monday. Tuesday is a whole mix of all sorts of rooty things. It's like 2 kind of mixed up days. There's like all these like little topics that aren't worth a day of their own, that they jump like 10 things into 2 lessons.